y equals x squared minus 3x plus 7 all over x minus 1. We need to do the division, and we could do long division here, but we can actually do it in a slightly quicker way than that by just changing this top line here and adjusting it with this x minus 1 denominator in mind. So let's just do that, shall we? So for there to be an x minus 1 here, I need to write that as x minus 1, and that will give me x squared minus, there's my x squared, minus x, and I've got a minus 2x here, minus 3x here, so I've already got a minus x, so I need a minus 2x. Now there's my minus 2x, but I've got a plus 2, I've got a 7, so I need to write 5 more to get the 7. So we've just adjusted it so that we can divide through by the denominator here. So this, just splitting up these three parts of the fraction on top then, the first part we'll just get an x left, won't we? The second part will have a minus 2, and then the third part will have a plus 5 over x minus 1. So this is what we want to sketch then. This is the same as this, so let's have a look at this curve then. So for x large, this tends to 0, and we tend to this value here. This dominates, so this is a straight line. Gradient minus 2, intercept 1, so let's just draw that on our sketch then. It's going to go through minus 2 and just be a straight line, gradient 1. So this value here is minus 2. So we've done that. Now when x gets large, this value becomes small but positive. So it's just above the line, isn't it? Because you're adding on a smidge to the line. So it tends towards that line in that direction. When x gets large negative, this value here underneath, large negative, is still large negative. Plus over a minus is a minus, and this becomes a small negative number. So you just take off a smidge off the x minus 2 asymptote, don't you? So it tends there. So what else changes? Well, x equals 1. This is x minus 2 of gradient 1, so that's 2 there. So if we want to put in the value 1, we need to draw an asymptote here, don't we? So let's draw an asymptote down vertically there at the value 1, which we've put in pictorially the right place. Now, as x tends to 1 from above, 1.1 say, this gets very small underneath, but positive. So this fraction is very large, positive, plus this number is still very large, positive. So it shoots up to infinity there. So that confirms what we would have thought. And as x tends to 1 from below, this is negative, small. 5 over negative small is negative large. Large negative. So it shoots off to minus infinity just below 1, doesn't it? Here and here. So it's going to come up, turn. The only thing of interest here is what value is it when x is 0? Well, we can see it's minus 7. So this is minus 7. So it's going to come up. It's going to turn somewhere. We don't know where the maximum is, and then it's going to tend toward that curve. I'm guessing it's around there. It could have been before or after. It could have come up a bit more steeply and gone like that. Or it could have come and turned on the actual point there as well. But for the purposes of the sketch, this is the characteristic shape of the curve. And on the other side, we're coming down from infinity, we swing round to a minimum, and then we shoot along to this asymptote here. And now we can label the curve. Y equals x squared minus 3x plus 7 over x minus 1. Let's get the plotter out. Here it is here. So we want to type in quite a long-winded thing, so I'll put a bracket around the top because it's more than one term. X squared minus 3x plus 7, all divided by, so close bracket, divided by bracket x minus 1. Close bracket, from minus 10 to 10 is fine. X squared minus 3x plus 7 over x minus 1. Yeah, and we can see what happens here. Here's the value 1, which we drew incorrectly. The straight line here, which we seem to have got correct as well.